Hello, everyone. It's Ms. Serrano, and we're going to go over today how to find solutions or the min or the max on the TI-83 and 84 calculator. All right, in this video, we are going to graph this function. So let me give you a little preview. There you go. And on here, we have to state what are the solutions, what is the local max, and what are the local mins. Now, if you see in this example, it looks like it hits the x-axis 3 different times. So those are our solutions. And it looks like we have 1 local max and 2 local minimums. So let's take a look at this on the calculator so you know how to find these values. Okay, I went ahead and I put in this equation into the calculator already. Let's take a look at the graph. There you go. All right, so just by looking at this, it looks like it hits at -3, -2, and +1. So since these look like nice answers and not decimals, I can actually look at the table. So second graph to get to the table. And we can see it hits the x-axis at -3 and -2 and +1. But one thing we have to be careful of is that here it hits in 3 spots, but the degree on this equation is 4. So I really need 4 answers, not just 3. But it's not terrible because here I can see it is tangent at when x is equal to 1. So if it is tangent, that means there is a multiplicity of 2. This answer counts twice. So if we go back to the page, we can say the solutions are at x equals -3, -2, and +1 with a multiplicity of 2. Now we could get those answers by looking at the table because those answers were nice. What if those answers are decimals or even worse, weird decimals? How do you find that? Well, that's the second way we're going to talk about. All right, the other way we can solve for these solutions is that we're going to use the calculate feature, which is actually written in blue up above your trace key. So to get to that function, we're going to hit second trace to get to calc. And what we want to calculate is the 0 of the function. So I'm going to hit 2 for 0. And let's try to find this first point right here. So this says left bound. So they're saying, what's the left side of this point that we want to look? Hit enter. And then you want to move, Mr. Blinky Guy, use your arrow keys. Hit to the right of that point, hit enter. Guess, that question's dumb. Texas Instruments took it out later because they realized it was dumb. So hit enter. All right, and it confirmed that answer as -3, 0. Awesome. Let's go to second trace to get to calc. We have to find the next one. Now I know what you're thinking, Miss Serrano, can't we get all 3 of these at once? Dude, I wish, but no, that's not how this calculator operates. You're going to have to get them all separately. Okay, guess, whatever. All right, -2, 0. Now we got to find that dude. So second trace, go to 0, number 2. All right, so let me get a little closer. All right, I'm to the left of that point, hit enter. Then go to the right of that point, hit enter. Guess, yeah, enter. And there we go. Now, sometimes, I don't know why the calculator does this, but sometimes you need to round it for it. So this, what do you think they're trying to say? They're trying to say 1. So this is really saying 1, 0. So let's go back to the page and we'll write down our solutions. And remember, this dude has a multiplicity of 2 because it's tangent. All right, we found out from the calculator that the 3 solutions, the 3 points where it hits that x-axis, are at -3, -2, comma 1 with a multiplicity of 2. Now let's go back to the calculator and find the local maximum. All right, back to the calculator. I like to start on the graph page, and we want to find what is the coordinate for this local max. So in order to do that, again, we're going to hit second trace to get to the calculate feature. This time, since we're finding a maximum, we're going to select option 4. And usually you'll see Mr. Blinky Guy somewhere on the y-axis and where it intersects with the graph. We want to find this spot, but remember, first we have to get to the left of that point, the left boundary, which, that's good. Hit enter. And then we have to find the right boundary, go to the right of that point, hit enter, guess, whatever, hit enter. And there you go. So I will say that max is at negative point, let's do 68, comma 8.64. All right, let's write that on the page. All right, so I'll write down the local max. Again, we said negative 0.68, comma 8.64. If your teacher wants you to round to 1 decimal place or 3 decimal places, whatever, just do whatever your teacher says. All right, now let's go back to the calculator and find the 2 local minimums. Okay, we want to find these 2 local mins. Now, I had one student one time ask me, can I do the left boundary over here and the right boundary over there so it gets 2 at once? No, I wish, but no. Okay, it will only do 1 at a time. So to find the minimum, we're going to do second trace to get to calculate. This time we're going to pick option 3. And it looks like Mr. Blinky Guy is where we left off for that max, so that's fine. I'm going to get the min on the left, so first go to the left side of that point, hit enter, and then go to the right side of that point, hit enter, yes, hit enter. All right, so we'll say negative 2.57, comma, we'll say negative 3.12. That looks good. And then we'll find the other one, second trace. And again, we have to say minimum. And let's get over to the left side. I'm going to get a little bit closer. That's good. Hit enter. And then we have to go to the right side of that point. Hit enter. Yes, hit enter. All right, ooh. I bet they're trying to say 1 here. And that one, if you ever see E to a negative number, this is the calculator's way of trying to write this in scientific notation. Because this is like 2.67 times 10 to the negative 11. Think about it, if you moved your decimal point 11 spaces to the left, what is that going to round to? 0. So it's trying to say 1, comma 0, but you kind of have to translate that a little bit. Never use an answer with the E and the negative number on there. Just don't. They're trying to say 0. So let's go back to the page. All right, for the minimums, the first one was at negative 2.57, comma negative 3.12, and the second one was at 1, comma 0. Now, we did already find 1, comma 0 as one of the solutions. Remember, that was the one that was tangent, but sometimes the solution can also be a max or a min. That's okay. That's just the way it worked out. And that's it for this video. Have a wonderful day, everyone. Bye-bye.